All right, I propose to get started. It's 1 minute beyond after 2, and we have a packed agenda with a lot of exciting speakers, so let's get started. Thank you all very much for joining. We're really happy to have so many people in attendance today at this webinar around sharing confidential data for research. My name is Hielke Koers. I am the Group Leader Data Management Services at SURF, and I also have the privilege and the honor to host this webinar today, and we're really excited about that. I wanted to start by also showing some data and setting an example, if you like. It's actually one data point, and the data point is 240. I think some people are now probably guessing what that is. I also think some people will probably have cracked the puzzle. It's the number of attendants that have registered for the webinar. And of course, that's a great number. We're really excited to have so many people in attendance today. And I think apart from showing how everybody is very eager to socialize virtually, that also really underlines the importance and the timeliness of the topic today. I'm personally not that surprised because the topic of data sharing really lies at the intersection of 3 very exciting areas. First of all, there is some cutting edge technology that enables new and innovative solutions. It also holds a promise to do good with data. Think about, for example, all the COVID research, and I'm sure that we have many people on the call today who are working on that as we speak right now and trying to get their hands on as much data as they can to further their research. And finally, it also touches upon larger societal questions, because if data is really the oil for the new digital economy, then of course the question is who should be in charge? And what checks and balances do we seek as individuals, as organizations, and as society at large? Now, disclaimer, we will not be touching upon and definitely not solving all of that today, but we do have 5 excellent speakers lined up who will share with you some of the projects and the solutions that they have been working on. I hope personally that you leave the webinar with a little bit more information and knowing more about these projects, but also with a sense of excitement and inspiration about what can be done and perhaps what could be done even more in the future to enable the sharing of confidential data specifically for research purposes. The agenda for today, we'll start with the keynote, and we're very happy to have Nanda Piersma join us to deliver the keynote. We'll do a very quick Q&A after the keynote, and then we have lightning talks, just 10 minutes, and then I ask everybody to save up their questions till the end, because we really want to have a rapid pace as we go through the lightning talks. So we'll do Q&A at the end of these 4 presentations for all of the speakers together. And then at the end, a bit of time for an audience poll, because we'd also like to get your perspective and use the opportunity to get some feedback from you, the people in the audience, and also discuss that with the panel in a live setting. So we've prepared a Mentimeter and then asking for your input, and we'll discuss that together. One logistical remark, if you have questions or comments, please use the chat to all participants option. We're also monitoring that, so do not use the Q&A if you see that. The chat is the best way to place any comments or ask any questions, and then we'll pick it up from there. So with that, I'd like to give the floor to Nanda. We're very happy, Nanda, to have you here as our keynote for this webinar. Nanda is professor in urban analytics in the joint research groups with the Amsterdam University of Applied Science and CWI. Her research focuses on the use of data in an urban context to support the digital transformation of cities. And since January this year, Nanda is also the scientific director of the Expertise Center for Applied Artificial Intelligence and a founding member of the Amsterdam Data Exchange. So Nanda, I'll stop sharing, then I ask you to share your screen, and then the floor is yours.
Yes, thank you. Now trying to share my, yes, here we go. Oh, and I don't know what you see, but I think you see the wrong one. I hope you now see a full screen.
Not yet, Nanda. We see starting to share content.
Yeah.
Seems like you still need to push one button to confirm.
Yeah. Let me see. This went well last time I did this.
Yeah.
Yes?
Yeah, we see it loud and clear. Thank you.
Okay, thank you very much. Well, thank you for inviting me here, and I think with the new job that you just introduced me with as Scientific Director of the Expertise Center for Applied Artificial Intelligence, I need to say a little bit more about that. Just give me half a minute to explain what this is. Who are we? We are a bunch of white guys and supporting female staff, so we have to do something about that. But the Expertise Center is located at the University of Applied Science in Amsterdam, and we want to bring AI technology in applications in society and industry. That means that we are not developing new AI technology, but we are bringing the AI technology into the industry applications and the societal applications. We do this in co-creation with experts in the field, and we want to design responsible AI. Also, since we are a University of Applied Science, we also train. We do not only train our students, we also want to train professionals that we meet while we are working in the labs. And we work for the Amsterdam region. Our labs that are already started, who already started, here you see that we have 7 labs already. If you're interested, you can contact me and we can see what we can do. So why do I start with artificial intelligence for this talk? Artificial intelligence is a winner-takes-all technology, and data is an instrument of this dominance. And we are now talking about data sharing and sharing data for research, but we are facing these superpowers that are either in China or Silicon Valley, who are using the data in a monopolistic way. There's an excellent book by Shoshana Zuboff. It's a bit of an activist book who talks about surveillance capitalism. So anyone who doesn't know this, I can recommend these 2 books to you. But if we look at the Dutch situation, then I'm sorry for the slide, it's not very well readable, but maybe you can. If we look at the other perspective of what are industry partners doing with data projects, and if you look at it, you say 24% is not doing any data-related research or any data-related projects, and almost 70% or more than 70% are running experiments with data, but they do not implement it. Only 50% is implementing AI application using data. So if we are in this experimentational state, what are the biggest challenges to implement data-driven solutions? So one of them is to improve improving data quality. And with improving data quality, there's also acquiring the data or sharing the data or working with the security, the compliance. People do not have the right technology. So I'm really excited that you are working on the technology to allow data sharing. This is, I think, one of the most important issues for industry. So if we look at the role of data in research and education, there are a number of issues that you may not be aware of. And one of these issues is that when we work with students or when we work with research, we are, and most of the times, we are relying on open data. And if we have confidential data, we usually need to find an NDA, a non-disclosure agreement. And that gives you issues with publishing your research. If you want to publish your research, you need to allow the reviewers to look into your data. You need to save the data, and you need to make it open data, preferably. Also with students, if you give them confidential data on their laptop, you don't know where it goes. So that's usually difficult, and that's why a lot of universities have problems allowing too many students in their programs. A second thing is that we want to use fair data, so it's findable, accessible, interoperable, and reusable. You probably are all aware of that. And we are facing some difficulties with data sharing. So there's a number of platforms, but the platforms, when you want to share big data sets, they're usually too pricey for a research program. Sometimes you have up to 50K of infrastructural costs for a simple project, and that's something you need to solve. So luckily we are working on that right here. There's one dimension that I can mention for the role of data in research, and that there's a difference between the sort of research that you do. And I like to sum it up in three ways. So academic research will bring new algorithms to the same data sets. You share the data can be shared among multiple research institutes. And what we want to do is to find better algorithms or better models. So you want to improve the performance by comparing it to the same data set. If you look at applied research centers, we like to bring the same algorithms to new data sets and new applications. And what we research is the application methodology. Why does this algorithm work on one sort of data environment and not on another data environment? And what can we do to find the best algorithms that will give the best application methodology? In industry, you need to bring both the algorithms and the data to the applications to improve the business proposition. And they don't care about the best algorithms, or they don't care about the best data sets. They care about data sharing, finding somehow a way to improve their business. And this can come to really difficult situations. As Leon Gommans will show you later, in the airplane industry for maintenance, all your data goes to Boeing, who is the producer of the airplanes, and you can buy your own data back. That gives a lot of difficulties that we need to address. On the other hand, if you say, okay, we're going to do it with regulations, the Tesla car, who is now on the road in the Netherlands, they are certified the moment they enter the market, in the Netherlands. But they have updates online. And with a couple of updates, you actually have a new product driving on our roads here. So is this a new product that needs to be certified again or not? And that's all data-related issues for industry that we need to address. So if we look at initiatives for data sharing, I can show you 4 examples in the time now. And one of the initiatives is European, 2 initiatives are national, and 1 is local. This in no respect gives enough credit to all the other initiatives, but I can do these 4. First one is the European Open Science Cloud. I think everybody is well aware of this one. And this is, for me, sort of a European answer to the dominating data partners that we have in China and in the United States, Silicon Valley way. And it aims to think about this in a European way. And this is a project that is already running for a long time. It's also on the agenda for the digitalization of Europe. And it's running since 2015. And if you look at the setting the stream, all the reference documents that you can find on the European Open Science Cloud now, you see all the basic issues are done here. So it's talking about fair data. It's talking about financial and governance of data sharing. It's talking about turning fair into reality. And this is a very nice project that has a lot of spin-offs in different countries in Europe, of course. So if we look at the Dutch initiatives, one is the initiative from the NLAIC, that is the Dutch AI Coalition, Artificial Intelligence Coalition, and they have a work group, Data Delen. And this work group shared in Dutch, I'm sorry, but you see a lot of English word for the non-Dutch speaking here. They shared their views of what the ecosystem of data delen, of data sharing should be, and they related to artificial intelligence. And I would really like about this ecosystem is that it shows the different roles that we like. So you have the business consultants, the technology consultants, R&D and innovation, certification and auditing. They also talk about how you can offer some services to the people who offer the data. And they say, okay, we can help you with identification, authentication, consent management, marketplace, etc. The relation to AI. So this is a way that we can build an ecosystem. But if we want to make it work, it has to scale really fast. It has to scale to larger data sets available to everyone. The third one is the National Data Sharing Coalition. And The National Data Sharing Coalition is working on a harmonization canvas. If we want to share data, then we need a trustworthy, reusable digital identities of this data set, and we need law agreements and semantics of data that we understand. So for instance, for the logistics sector, everybody will save the data in the same way. That would be really helpful. I'm working on a project for data integration with the waste collectors, major waste collector companies, and everybody is saving their data in a different way. One is doing it in kilos, the other is doing it in loads, and everybody's doing it in a different way. So it's a very interesting project. They just started the 20th of January, and they are working really hard to get some ideas working here. Finally, a local initiative that I was part of, that's why it's really close to me. This is the Amsterdam Economic Board started together with the SURF and a couple of people, the AMDEX, this Amsterdam Data Exchange. And what is so interesting about this part, it is a platform where we do not have a central control of data sharing. We want to find a platform where we can use technical support, governance support, to have people control their own data and share their data with other parties in the market. And they can have their own financial agreements if they like, but we don't care about what the financial agreements are. We just want to give you a trustworthy platform where you can share your data. This part was you see some of the other speakers that you will hear now are also part of this initiative. And in 2019, there was a competition by the municipality of Amsterdam, and the winners were Maastro and Dijkstra, and they are actually building a platform using these principles. So these are just 4 of the initiatives in data sharing. There are many more business initiatives, as I told you, so I hope that there is new ideas that we can use. So to sum up, the takeaways that I want to show you, not going into all the technical details, but it says that industry, applied research and academic research, they have different needs or different goals for data sharing, and they also have a different idea of how to share the data. If we look at the industry, especially the Dutch industry that I looked into, they are in an experimenting phase and not in an implementing phase using data for the businesses. So we need to help them at the right time with the right experiments. And we are still formulating a European answer to the dominating data identities. As I told you from Boeing and Tesla, we need to find an answer to work with entities that want to dominate. But the current status is we all find the urgency, we all know the urgency, and it's not why we do this, but it is how to do this. And I'm really happy to see that both the CBS, the Health Vein, and the KLM data applications are now experiments that are practically a long way. They actually have working examples of how to do this, and I'm really excited to hear the other speakers. So I'll keep my time and give back the word to Hilke.
Thank you very much, Nanda, for that great overview. And I really liked how you talked about the why and the what and the how, and at the end, the call to action to start doing things. We definitely recognize that. Thank you very much.
You're welcome.
I'd like to open it up for 1 or 2, maybe 3 questions. If people in the audience have a question, please type it in the chat. We'll take questions by chat, and then I can ask them to you, Nanda, and you can respond. Maybe I can kick it off with 1 question while others formulate a question in the chat window. Nanda, zooming in on the AMDEX, the Amsterdam Data Exchange. What do you think is going to be the next big step there?
Well, the big step is to get an actual platform that works and that can build the trust. And if we are all looking at some experiments that are very locally or just for one partner available, then other people may hesitate to share their data. So I think we should have a working platform that can use multiple experiments.
Yeah, thank you very much. There's a question from Nico Populier asking, when will we see a European company providing the same services as Microsoft with Azure, Amazon, etc.?
Well, not the same as Microsoft and Amazon. I think that will take a long time because they are so big and they made their money in a different field. So if you see the amount of money that they have for innovation, that's so large. I think we cannot compete with that in the near future or in the longer future. I think in the European way to look at data sharing and in the European way to look at research data, only together we can make a difference.
Yeah, great, thank you very much. We have a question from Hidde Eidhoff, who is asking, are you working or looking at blockchain solutions?
Yeah, I think blockchain is a very nice technique, but it's just one of the techniques that we can use. And it's mostly used in finances and now in health environments. And so it's a trustworthy potential technique. But I think there are other techniques, and I think someone from Surf will talk about that later.
Great, thank you very much. And yes,
You're welcome.
Freek will talk about some of the techniques that we are looking at. Excellent. One last question from NM Koster. How is Surf involved in your activities? And I think that's a question for you, Nanda, so maybe you can answer.
Yeah, well, maybe it's the other way around. How can we use Surf for our activities? It's mostly facilitating and with the larger computers that they have, but also with their knowledge of how to do the things. So we have a nice partner in Surf to relate to each other. How can we make applications work? And that's a really nice partner.
Yeah, great. Thank you very much. And also Freek, my colleague here at Surf, has a presentation as one of the lightning talks. So that will also illustrate some of the things that we're doing and how Surf is contributing. Nanda, thank you again very much. This was very insightful. Great start. Thank you. With that, I'd like to move to the lightning talks. And the first speaker in that part of the program is Ruurd Schoonhoven. Ruurd is the Senior Relations Manager Microdata Services at CBS, Statistics Netherlands. And he supports research projects by external institutions, promoting the use of data that CBS has for the benefit of society as a whole. Ruud, the floor is almost yours. Just one reminder to everybody that we'll do a Q&A at the end of the lightning talks. So if you have a question for Ruurd, please already put it in the chat or write it down. And then at the end of the 4 lightning talks, we have time for Q&A for all of the 4 speakers. Thank you very much. With that, Ruurd, the floor is yours. Thank you.
Yeah, thank you very much for your intro. And thank you for the opportunity to give this presentation here. As you all know, CBS is the Dutch Office of National Statistics. And we collect data from a wide range of organizations in the country. In the past, mainly interviews. This has shifted to online questionnaires, but the vast majority of data that we collect nowadays is from administrative registers from all kinds of government and other organizations. Here I give a number of examples of such registers. The interesting thing for registers is that they contain all Dutch people, so all of your data is included in these registers. And these cover areas like the population register, other what is called basisregistraties in the country, information on jobs, social security, education registers, lots of health information, but also companies, the Chamber of Commerce, databases, tax data, quite a few, well, etc., etc. And it's maybe evident that many of these data are quite sensitive, privacy sensitive. Now, what is microdata services? Well, microdata, to start off, microdata is what we call individual record data on individual persons or companies or institutes, schools, hospitals, etc. CBS is governed by CBS law, and CBS law has created the opportunity to give access to research organizations to these data under a number of conditions so that they can do their own research on this data, statistics. Well, privacy is very important all the time. So to start off, all microdata are pseudo-anonymized. There are no names, no addresses, just general info. The data remain within CBS in a secure network, and you can work on it, but only take home statistical aggregates. You can run your projects once your institute is authorized, and projects run based on a need-to-know basis. That means that you can only get access to those data sets that you need to answer your pre-described research question. There is a remote access facility, and then there are some other conditions which, well, also important, but maybe not for this specific meeting. This is a visualization how it works. On the left is, well, the CBS network environment. It's completely closed. You cannot mail, you cannot print, you cannot connect to the internet. It is a closed network where these microdata are made available and where you can analyze them with all kinds of packages, Python as well, and well, that's moving over time. And to the right, you see the remote access method, which is that you can connect to the network from your home computer using a VPN connection with a two-step authentication with an RSA token and a code that you receive as an SMS on your mobile phone. So this is a more or less like internet banking, you may say. And this is the way it works. And the two arrows indicate, well, the blue arrow indicates that if you have finished some of your analyses, you can get your outputs, but these outputs are first checked by personnel from CBS to see whether it does not disclose information about individual persons. That's the blue arrow. The black arrow indicates that you can also, under certain conditions, import your own additional data sets for linkage. Well, we have a catalog of microdata. When you make a quick look through this slide, you will see that it covers a wide range of subjects. And all these data sets, well, there are about 400 topics, and they cover a time span of 10 to 25 years. And again, I put here the option to bring in additional microdata. And this system has been running since early 2000s, so between 15 and 20 years now. And it has grown substantially over the last years, so that now over more than 1,000 individual researchers are using it, mostly within the Netherlands and also a smaller part abroad. Well, what is the major added value of this? That is that all data sets can be linked together at individual record level through linkage keys. These are meaningless numbers, IDs, identifiers, but they are meaningless for persons, for companies, for addresses, etc., etc. And this allows research across different teams. And this is the major reason why this is so valuable. This picture gives an illustration of that. When you take persons in the middle here, you can connect for individual persons, their household composition, their education level, their income, their labor, their careers, their health use, their whatever, criminality, mobility, how their housing, what kind of houses they live in, regional address information, or at least, aggregated regional information. So this is a very rich collection of data that we offer this opportunity, this facility for. Then, well, I think I'm going very fast, but that's good. And then we can take more questions. An interesting interesting expansion of this over the last few years is that we now have Odyssey, which is the open data infrastructure for the social sciences and economics. This is a collaboration project between about 40 institutes being faculties of social sciences and economics, but also government institutes like the planbureaus, the RIVM, and some other KNW-based institutes. These institutes have decided to work together in the field of data infrastructure for their field. And together between Odyssey, CBS, and SURF, we have realized the opportunity to expand this facility with a connection to the Cartesius supercomputer in Amsterdam, so that we can offer the opportunity to make much more heavy computational analysis on these data. Because as you may understand, if you have these large data sets like 17 million Dutch, and you link many different variables, or you make a network of connections between the Dutch persons, the Dutch inhabitants, then you will easily get data sets growing really big. And this is a very, very novel development over the last 2 years, and it's very promising. So that's in a nutshell what I wanted to explain. There's much more to tell, and you can find lots of information on our website, Dutch or English, whatever you prefer. Well, if you want to browse that, please go ahead. And if you have more questions, you can always contact us. And there's some information here that you will also receive in the slides that will be distributed after this afternoon. Thank you very much.
Wonderful. Thank you very much for that presentation, Ruurd. Excellent. Thank you. Just a reminder for everybody, if you have questions, please put them in the chat and we'll pick them up in the Q&A at the end of the lightning talks. I see Anand Gavai has already done that, so that's great. Thank you very much. We'll pick up that question at the end. Thank you, Ruurd. I'd like to move on to the next speaker, and that is Ananya Choudhury, who is a computer scientist working as a clinical data scientist at the Maastro clinic in Maastricht. Her research interests is in distributed machine learning algorithms and infrastructure, as well as the FAIR data principles. She's an active community member of the National Personal Health Train Network, and she's currently working on a research project around distributed deep learning from medical images with the Personal Health Train. So that all sounds really exciting, and we can't wait to hear from you, Ananya. Can you share your screen, please?
Thank you, Helge. Thank you, Sarah, for organizing this very interesting webinar, especially during these times when we are forced to work from home. This is really a very nice way to connect with everyone. So moving on to the presentation, give me one. Okay. So personal health train is an idea, since we are talking about sharing of data and how there are barriers of sharing of data and not readily doable. Personal health train is a metaphorical name of an idea and an infrastructure where we share data, or rather share insights and analytics from data without actually exchanging the data. So in all the process of machine learning or analysis of the data always stays at the source. Now, let's look into this. An example from cancer. So we talk about big data and the importance of big data and technologies like AI and machine learning for improving not only treatment and diagnosis in healthcare, but it's equally important for in any other departments, basically. So worldwide, between 2007 and 2017, there were 150 million patients. So that's really a huge amount of data, with each patient contributing around 10 gigabytes of data. That sums up to be around 1,500 petabytes of data. Well, that's huge data, and when we talk about how much evidence we can gather from this data, probably this is a best case scenario, but it's not always best. More data equal to more evidence, means more insights and better treatment. But the problem is twofold. Firstly, these data are not available in a central location. All these data are spread at geographically distributed locations and are trapped mostly within hospital databases, basically, which are difficult to extract. And since healthcare data is really very confidential and sensitive in nature, the hospital are not allowed to share this data without proper consent. And also with laws like GDPR, it's even more difficult. That's one part of the problem. The other is, even though we have the correct authorization and the rights to share data, these data are not readily usable. 80% of the data are unstructured. They are not understandable in terms of how it's organized, but also how we understand the meaning of the data. So this makes it difficult for sharing data. And it can be termed as the health data Goldilocks dilemma. Whether we want to share data, and while we are sharing data, means we are compromising on privacy. So if we are ensuring privacy, then this means that we are limiting our sharing of data. Now, what happens when we are sharing too little health data? This means that care providers would not have the best information for clinical decision making. Clinical researchers would be stifled from conducting groundbreaking analysis and studies. Next generation technologies like AI and machine learning would be stopped. And promises of personalized medicine would be repressed. Now, what happens when we share data a bit too much? We are compromising on privacy. Trust in care providers and the healthcare system would be eroded. And value created by these health data can be captured and misused for commercial purposes by third parties like big technology companies. So where do we focus on? Whether to go for broader data interoperability and data sharing or enhanced privacy? Well, there's always a dilemma. Now, when there's a dilemma, there has to be a solution. So just to look back into the barriers for data sharing, so it's not really technical that we cannot. The problems are more ethical, political, and administrative. As I said, administrative because I don't have the right resources. Political because I don't want to. Ethical because I'm not allowed to, governed by laws. And lastly, technical, which is not of that much importance, as I don't know how to share data. Well, we all know how to share data, so I would conclude that it's more administrative, political, and ethical. So when there's a problem, there is a solution. So if the problem is sharing the data, do not share data. Let's not share data at all. Instead, share the algorithms or the analytics. By this, we mean that if we are not able to bring the data to the algorithms or to the applications, we are pushing the algorithms to the data. By this, we ensure that the data stays where it is, whereas the mobility now comes to the part of algorithms and analysis. And that's what personal health train is. It's an infrastructure to send these algorithms to the data source. Now, it's not that simple. As I said, one of the problems is that the data is not structured. It's not interoperable. It's not understandable by machines. And I will show it in a slide next, why it's impossible for the machine to understand the data. But also that the research applications needs to be distributed. Classically, for all the machine learning tasks, the algorithms are built in a way that we always train the algorithms considering that data is always available centrally. Now, there's an additional task of distributing the algorithms mathematically and making ensure that it's easily communicable. If you look into this example, so these are basically data extracts from two databases. There are variables names. We can see that both of them are CSV data files. But if we want to extract the data with the same query, so if you see, the variable names are different, but they essentially means the same. Clinical T stage is cancer stage or N stage is cancer stage, histology, and smoking status of a person. So both the tables basically speak about the same variables. But if we want a script or a query to understand both the data or both the names of the variables, it is seemingly impossible. So we have to make sure that the data is interoperable not only structurally, but also semantically, that their meanings are always retained the same. And these can be done by using terminology and coding standards like SNOMED and WHO International Classification of Diseases, and there are various other ontologies which are globally used, accepted, and are in practice. So that means we need to have the data as findable, accessible, interoperable, and reusable. It's a prerequisite before we can start our distributed analysis with personal health. So within our group, a lot of research is also done in terms of how we can make all the data fair and how we can integrate data from multiple sources. So when we are talking about healthcare data, there are radiology departments which contains images, clinical data, but also data recorded from patients' individual healthcare devices like a smartwatch, etc. So all these things makes distributed machine learning extremely difficult, but not impossible, let's say. Sorry, my slide deck is stuck a bit. Can you still see it? Sorry.
We're still on the slide that says example, Ananya.
Yeah. Okay. Yeah. Now it's moving.
Yeah, it's moving.
So, yeah, this is the infrastructural setup of the personal health train, where we have various components. The researcher, a researcher is the one who wants to perform a research on distributed data sets. There's a central server, which is essentially a communication medium for the researcher and the data station, and the metaphors train, fair data station, and tracks. So tracks are basically the routes where we send the applications to the data stations, and trains are the wrapper which contains the algorithms and the query. So presently we are using Docker containers as trains, and these Docker containers are sent via the tracks to the data stations. Now the data stations provide an access to the fair data repository and also to the execution environment. It also provides an execution environment for the train. So we have applied personal health train in various scenarios, one of which we showed that we can scale personal health train to incorporate a machine learning run, including many thousand patients. There is a recent publication where personal health train is applied across 20,000 and more lung cancer patients to predict survival from these patients, basically. There is some lag with my presentation as I'm still struggling to move it to the next slide. There was an animation which you can look at later from the link from the slides that will be shared with you. So one of the very basic use case is a patient cohort analysis. Even before we do a machine learning run, we need to understand the characteristics of the patients that is there in the database, hospital database, in a fair data repository, understand how many patients we are recruiting, the statistics of the patients, and etc., which is a very simple but basic application. Then we have applications where we have tested it on 20,000 lung cancer patients from different 8 healthcare institutes from across 5 countries, and we used it to predict 2-year survival of the patients. Other important applications recently we have done is also for survival prediction for anal cancers from distributed data sets, which contains Maastro, Toslow, and Leeds. And we also showed that personal health train can be applied for distributed deep learning. We used it for survival prediction from CT images. We are still in the phase of submitting the publication. So these are some of the publications that you can look back later when I share the slides. Other areas where personal health train has been applied or are currently ongoing projects are lung cancer, head and neck cancer, rectal, anal cancer, esophageal cancer, Alzheimer's and dementia disease. Also with COVID-19, we are trying to apply and cardiovascular disease prevention. So I'll just take one more minute to sum up. So in January this year, National Healthcare Personal Health Train Network has been formed, and various organizations have come under the same roof where we learn from each other, and we basically work together to improve personal health train and see the diverse field that personal health train can be applied. You can visit the website and look into the many different use cases, some of which I have discussed here. There are plenty of others, some of it might be interesting for you, and there are always opportunities for collaboration. We have currently collaboration in almost all the continents across the globe, and this is just part of the team that we work on. With this, thank you again, and yeah, stay connected and learn more about personal health training. Thank you.
Great, thank you very much. Say, insights delivered. We saw some questions coming in. Gentle reminder to please send it to the all participants, because only that way also the people in the panel see the questions. Thank you. I'd like to move on, and then we do the Q&A again at the end of the lightning talks. So the next speaker is Leon Gommans. Leon, welcome. So very happy to have you here.
Thank you.
Leon is the Science Officer for Air France KLM. His main research topic is in data exchange systems supporting digital data marketplaces. Leon is also the endowed professor for data exchange systems at the University of Amsterdam within its Systems and Network Engineering Lab. And Leon is also a founding member of the Amsterdam Data Exchange. Leon, the floor is yours.
Thank you, Hilke. Is my screen shared with everybody?
Yeah, we can see it fine.
Okay, good. Well, thanks very much for attending this webinar, and also thanks to Sir for inviting me to present one of the developments around data sharing called Digital Data Marketplace. Since the end of 2018, the University of Amsterdam, in collaboration with SURF, has been involved in architecting and helping design and implement the prototype of a digital data marketplace for AI development as a research project with technology partners Equinix, Dell, Nokia, and Sienna. What is the challenge we are trying to address? Within operational industrial environments such as aircraft maintenance, decision support systems that use real-time or near real-time data from aircraft can help make decisions, for example, to plan maintenance, predict or even prevent events from occurring. Such decisions can help make maintenance more efficient and effective. Traditionally, a decision support system contains programmed logic that, for example, say, when this and this parameter rises above this threshold, raise an alert to decide whether a maintenance action should be performed. However, with the availability of more parameters and data, AI is becoming increasingly popular as a method to make such decisions. In our case, AI algorithms training includes learning from data generally generated by aircraft or by maintenance engineers and many sources. We can use data from our own fleet. However, algorithm accuracy will typically increase if more data is available. If an algorithm is allowed to learn from aircraft that are owned by other airline operators, the accuracy and typically applicability could be improved. Making more data available, however, is only possible if you want to achieve a common benefit, such as improving accuracy and ultimately safety. And that's something which you can address as an industry-wide topic. Here we collaborate with an industry standards organization called SAE, the Society of Automotive Engineers, which started over 100 years ago with standardizing spark plugs for both automobiles and aircraft engines. SAE is a well-recognized body in the world. With an initiative called ExchangeWell, we are now looking at making more data available for competitive AI development within both aviation and automotive, in order to overcome the reluctance to share data by clearly identifying the common benefit no single organization can achieve on its own. Identifying the common benefit is the first step in the approach we take to enable data sharing. After identifying a common benefit, such as achieving higher accuracy, the next hurdle is to take is creating rules. We often see that creating contracts between organizations, in particular if they are negotiated in a peer-to-peer fashion, may take a long time. A digital data marketplace may help create contracts as templates, arranging data access and usage, and most importantly, benefit sharing in a commonly agreed way. The next step is to organize further evolution of the rules, ways to administer and enforce the rules, and also how to resolve disputes by creating an organization that operates the marketplace. This organization has the mandate to organize the rules such that they become a means to reduce risk, allowing trust to emerge. As such, a consortium can subsequently arrange a trusted infrastructure that can execute AI learning processes, and that's then done in the infrastructure. Here you see a workflow along which a digital data marketplace could work. A consortium can obtain a neutral infrastructure that is placed across multiple locations of a neutral and well-connected data center infrastructure, connecting and interconnecting many cloud infrastructures. Public clouds can provide a large variety, for example, of data science workbenches. Private and public clouds provide places where data owners store their data. After the consortium has obtained the key of the central marketplace infrastructure, it can start to admit members that can subsequently start with registering their assets, being data or algorithms. And that's something they want to offer for sharing as a kind of a product. Contracts or trade agreements will subsequently arrange which members can see what assets of other members. Based on such agreements, a data scientist can start exploring options to create feasible algorithms that subsequently need training. Training is arranged as a transaction that is put as a smart contract on a blockchain. The transaction defines a data science pipeline that is submitted to the digital data marketplace for execution. After completion of the execution, usage details are logged also on the blockchain, maybe using some coin mechanism, logging as such the usage and access of data, which could be monetized if chosen so. Here you see what the data scientist sees just before submitting a pipeline. That's part of the prototype. He selects the algorithm, and then after obtaining access rights, he can also select data sets and then push the execute button to submit the pipeline to the digital data marketplace infrastructure for subsequent training. Below, a part of the screen tracks the status of the submission and allows inspection of its progress. So now you're curious to see how actually the infrastructure looks like. To train AI algorithms, there are essentially a couple of options. You could send the data to the developer, or as we just saw, the developer can send an algorithm to the data. Both options have advantages or disadvantages, in particular when you talk about full control on the data. If you centralize the data, then that will be lost. Data owners, therefore, don't like the centralized models, and developers may not like the distributed model, fearing loss of algorithm IP, but that's how you arrange it. The observation brought us to the third alternative, the federated analytics approach, in combination with a consortium governed and secured infrastructure. Here you see how the security architecture built around this idea looks like. Every data has its own market stall on the digital data marketplace that maintains, under full control of the data owner, its data. The developer is able to submit the data science pipeline, which I just showed in the example, and then it gets automatically deployed across the different places for training. Here, the algorithm learns separately and near the data via federated learning, and the learned weights are combined into a single result. And that single result is then handed back to the data scientist and not any of the local data from any user, any supplier. The federated learning results are essentially created based on authorizations to access and use the data via contracts that are created via the marketplace software from Nokia's solution that's called Database. And during the experiments, Dell provided open source solutions and their own solutions, such as Milky Way, to implement federated learning. Equinix provided a global neutral data exchange facility. To conclude, here you see the entire architecture of the digital data marketplace. A consortium such as HvA ITC Exchangeable organizes the marketplace by creating rules, admitting members, and creating standard agreements. Members, being data suppliers or developers, can subsequently, and in competition with each other, create agreements that allows then the data scientist to use one of the previously shown ways to create data science pipelines that are then submitted as transactions to a globally available data exchange infrastructure. So you also see dispute resolution as a key element needed, and to do this, you need also every transaction to be logged on blockchain, so you can do this kind of dispute resolution. We have implemented a prototype on 3 data centers in our testbed. One is located in Silicon Valley, the other at the University of Amsterdam, and one at a KLM data center. So this was a very short introduction of the digital data marketplace concept, and if you need more information or interested, please let us know. Thank you.
Wonderful. Thank you very much, Leon, for this very thorough overview of what's happening at Air France KLM. Thanks a lot.
Thank you.
With that, I have the pleasure to introduce the last speaker of our session of the lightning talks. That's my colleague, Freek Dijkstra. Freek started his career as his training as a physicist. He has a master's degree, then did his PhD in computer networks, and now describes himself as a bit of an amateur programmer. More pertinent to today, he is also the project lead for the CWI data exchange, and Freek will tell you all about what that is and how we're approaching that at CWI. Freek, the floor is yours.
Thank you, Hilke. And I'd like to start actually by answering the question of Adam Costa previously, how CWI involved in all of this. Well, we're not just only sharing data, but we are also sharing knowledge here, and there might work a few smart people at CWI, but the real experts are obviously the previous speakers. So let's talk about our take here on data. Oh, next slide, please. Yeah, there we go. So if you look into data sharing, there's actually a disbalance, in our opinion, between the data provider and the data consumer. For the data consumer could be the researcher who likes to access confidential data. And that researcher, if they get access to that confidential data, have the gain, they have some benefit there. But the burden, the risk is usually at the data owner. So there's a disbalance there. And one way to solve that is that the data owner gets more control how that data is being used. So let's focus a bit here on the data provider and their willingness to share data. And actually has to do with 2 balances. The first of all has to do with their gains. So there has to be some inherent gain for them to share data. If there's no gain, they will not do it, how much technical solutions we throw at it. So, for example, they could get some monetary benefit, but also indirectly, for example, they get, if it's a research, they get citations, or the data set will be cited. And because of that, they could get more easy funding, for example. So that's the gain. And of course, that has to be a positive balance between the gain and the effort. So the gain has to be higher than the effort they have to take. So that's the gain side. The other side is really the trust side, the control and risk. So there's also an inherent risk in sharing confidential data. Risk is inherent to it. If data is leaked, there is a consequence. For example, bad publicity or privacy could be violated, or business critical data could be leaked. And that can be solved by control. So the risk and the gains, we can't influence it, but we can look at the effort and the control. And in particular, the solution we looked into, it has to do with control. So how can we increase that control? So what Leon already mentioned is you could not just send the data to the researcher, the data consumer, but instead send the algorithm, the analysis of that data consumer to the provider, or in this case, to a trusted third party, so to make it easier for the data provider, so lowering the effort. So the data provider in this picture is sending the data to a trusted third party or sharing it with a trusted third party, and the data consumer, the researcher, shares the algorithm, the analysis with the trusted third party. And once that's done, it's put in a secure container and it's being processed, but only after the data provider gets some checks and balances, gets some control over it. So for example, they first have to review the request. And what can they check? They can check the affiliation, they can check the code. So what do they check? And actually this is exactly the purpose why we built a prototype, not to build a service that's being used in production yet, but first of all, before we do that, we like to understand this problem. So one of the issues we like to understand is what type of control does this data provider have? What types of checks and balances are they going to do? Are they going to check the affiliation of this researcher? Are they going to check what purpose they have with this research? Or are they going to check the algorithm, for example, for nefarious code or known exploits? And if that analysis being done inside such a secure container, in this case a Docker container, then we have a result, and that result might still contain some confidential data. So they get another chance to look at it. They have a chance to inspect that result before it's being released to the researcher. And the whole, if that all works, we have actually a happy data provider because they're still retaining control, and on the other hand, the data consumer actually gets the result. So that's great. So how does it work? So I have a few screenshots here. How that works. I want to have some live demo, but because of time constraints, I'm not just showing some slides here, some screenshots here. And the screenshot you see here is a web browser from the data provider. This is the one with the black bar on top of that. So this is a data provider, and they share where some cats and dog pictures and also random numbers. So cats and dogs, so you can do some machine learning training to distinguish one from the other type of animal. And the random numbers is just some numbers they share. And what you see there on the right side, they share it, but they do not share it with the research. They don't share it with the data consumer. They share it with the data exchange. This is trusted third party. Similarly, and this is the web browser of the researcher, the data consumer, they share their analysis, their algorithm with the data exchange. So here are two very simple examples, some Python scripts called calculate sum and calculate average, and they shared what you see here on the right side of the screen with the data exchange account, in this case with Research Drive, the platform where you can share data. So now the researcher is sharing the data, sharing the algorithm with the data exchange. What they can then do is log into the data exchange, and this is the prototype that we've built, and check, okay, I select my algorithm, which I just shared, and I'm going to make a request to the data provider to run this algorithm on a specific data set. And they can do it just once. For example, they can ask, okay, I have this algorithm and I like to run this on this specific data set. But they can also do some more advanced type of permissions. For example, they are still developing the algorithm, and because, well, they don't never see the data, they like to do some debugging and programming still. So they can ask, for example, can I run any algorithm on your sample data set? And once they do that, they run it a few times and they're happy with the result. And when that's done, they say, okay, now we're done with this trial run, and now I'd like to share this final algorithm and run it on your actual data set. So here's a request to do a run once a calculation. Just calculate the sum of some numbers. They ask, they select the data owner and do a specific request. And then the data provider sees this request. So this is the website they have. So this is the black bar. So this is again the data provider side of things. And they see this request coming in. It's coming from a data owner, which is in the left side top here. It's from some researcher apparently working at Surfsara, and it's a one-time permission. Now they can check, okay, do I trust this particular researcher? And what type of permission are they asking? And what type of algorithm are they want to do on their on my data set? In this case, they have to calculate the sum, and actually you can even see this code. And more importantly, they can also see some dependencies. So this is one question: okay, what type of checks do a data provider wants to do before they allow a researcher to run their analysis on the data set? So here we have it. So we have all the data here, and they can say, yes, I'm agreeing with this run, or don't. So if they don't, they reject the request. Obviously, in this case, they can just run the algorithm. So let's assume that they trust it and they run the algorithm. What happens then is that a secure container gets built, the analysis software, so the algorithm is installed, the dependencies are installed, So they have some network access there, but only after that is being done, if those dependencies have been installed, then the network is closed off, and only after that the data is being mounted inside this Docker container. So because of that, the data never gets to leave this Docker container. So it's really a secure container in that sense. The algorithm is being checked if it's not modified in the meantime. It's being run, the output is saved, and after that, only the output is saved, but the rest is thrown away. So it's temporary. So all the data is no longer at the data exchange, but still at the original provider. And the algorithm is also still at the original researcher. Only output is stored. And before that's being released, this data provider still gets a chance to check this output. In this case, the output is here on the right side. So it's output some number 3717, which is apparently the sum of all these things. And I can check, okay, does it have any confidential data? And if not, so yeah, well, they might reject the output. If they think, okay, this is perfectly fine, I'm willing to release this to the researcher, they can release the output. And only after that, the researcher finally gets to see the run of their analysis and sees this result. So with that, the data provider has a chance to share the data, so to speak, or allow a researcher to use or tap into that confidential data. And the researcher is happy because he gets a result, and the data provider is happy because they hasn't shared it other than with the data provider. Other than with the data exchange, trusted third party. What's also important to mention is that for the runs, which are continuous permissions, they can withdraw their permission at any time for whatever reason. So if this researcher requested to run any algorithm on some sample dataset, they can still withdraw that permission at any time they like. So the data provider is still in control of their data. So what's the next steps here? First of all, what we like to have a better understanding of the needs and requirements of both the data consumers, or the researchers, as well as the data providers. And what this webinar is obviously an example of getting to understand the needs and looking at the use cases. So we have this working prototype, but now we're looking to, okay, does this rhyme with actual use cases, actual cases that we know of? So we're working with potential pilot partners. We are integrating with the Odyssey data node. We talk with other interested partners, and if you're one of them, I'm really happy to hear about it, because the more we learn how confidential data is shared and what type of constraints there are, what type of control there is needed, and what type is still acceptable for research and how the workflow works, the better we can understand what type of service we might offer in the future. And to start with, we're going to make this demonstration available to everyone. It's still there, but right now you need a Reserve Research Drive account. If you have that, we can actually play around with it. And we strive to make there, for example, some other type of account that more people have available, like Google Drive. And we'll do that by the end of the summer. So I invite you to just play around with it and see how it works. And the last thing I like to mention before Hilke cuts me off is this is not the only way we can actually share confidential data. This is just one technology there. It's just one way we can bring control of this. In this case, we provide a secure container. But for example, pseudonymization is also part of it. So making sure that if you do it really well, for example, with synthetic data, you might have some records which are just never linked back to an individual person. And if that works so well, maybe that would be a solution as well. And you don't need secure containers because the data is no longer confidential. That would also be a solution. And of course, like Leon mentioned, dispute resolution with legal agreements over here is also a solution. So there are many solutions, and we try to understand which solutions work best for which applications. And with that, I hand over the word to Hilke.
Excellent. Thank you very much, Freek, for this enlightening presentation and demo. Hopefully also that gives everybody a sense of the kind of activities that we're doing here at SURF, apart from organizing a webinar like this one. I'd like to take between 5 and 10 minutes to do some Q&A, and then we'll close the webinar by also soliciting your feedback. We have a Menti prepared, and then also ask the speakers to weigh in on the outcomes of that of the Menti to make that also a bit of a panel discussion. But before that, some Q&A, and we'll do that on a first come, first served basis. So I'm going through the chat, and I'll pick up some questions for any of the speakers so far. And actually, before we do, let me thank all the speakers one more time. Nanda, Ruurd, Ananya, Leon, and Freek. Thank you all very much. I think collectively that gives a great overview of all the activities that are happening in this space. So again, thank you very much. This would usually be the place for an applause, but that's a bit hard to do virtually. So virtual applause all around. All right, let me scroll up in the chat window. So the first question is, sorry, hang on, my chat is scrolling up and down all the time. A question from Anand Gavai to Ruurd, I believe, asking why authorization is required for CBS data, i.e., is it not supposed to be open with preset conditions for its use, or without preset conditions for its use? So Ruurd, could you comment on the need for authorization for CBS data?
Could you please be so kind to repeat your question, because the sound was
you are still muted.
I'm not muted now.
Sorry, no, we can hear you. My bad. Please go ahead, Ruurd. We can hear you. Seems to be something wrong with Ruurd's connection. I'm going to skip to the next question and then give Ruurd's connection the opportunity to get back up. There was also a question still from Nanda that came in, a question from Arie de Haan. How do you want to deal with data ownership from companies like Tesla and Boeing and use of that data in the European or the Dutch context? Nanda, could you comment on that? Do we still have Nanda, or have we lost Nanda? Looks like Nanda dropped off. All right. Ruurd, let's go back to you.
Let's try again.
Yeah, we can hear you fine. So Ruurd, the question was, why is there a need to authorize yourself if you want to make use of CBS data? Could you comment on that?
Well, because the data is very confidential, this data is not open to everyone. That must be obvious. And we are governed by CBS law. CBS law has an article which says that the Director General of CBS can grant access to these data to specific categories, like one is the Dutch universities, then second, Dutch planbureaus, and then research institutes created by law. And then there is a rest category, but the criteria is that you are working at a research institution which is really research oriented and which publishes the results for the general public. So you need to comply with these requirements before you can be given access. And then you have all kinds of contracts and confidentiality statements that you have to sign, etc., etc. But this is a restricted facility for research purposes, statistical purposes.
Yeah, excellent. Thank you very much. I think that addresses that question. Moving on, Arie de Haan had a question which I believe was posed during the presentation of Ananya. Arie asks, if you share the application and results, are you also the one to choose the application or algorithm? Ananya, could you comment on how that works in the personal health train model?
I slightly lost you for a couple of seconds. If you can please.
Yeah, the question from Arie is, if you share application and results, are you also the one to choose the application or algorithm? I think the question is, how much authority does the data owner have in terms of selecting which trains can dock the station in that analogy?
Yeah. So usually the way it works is that a couple of parties agree to start a study on a data set. And the researcher essentially is one from among the two or more parties who are involved in the study. So in a way, it's a consortium decision to run which algorithms he wants to. Currently, the setup works this way, that we set up a collaboration based on a study and the project partners. So the project partners or the researcher can choose, definitely provided there is an algorithm which can be run distributedly. But as a runtime selection with the infrastructure and the process, it's still not there in place. That's it. So it has to be pre-selected which algorithm we want to run on which data stations.
Excellent. Thank you very much. I think that clarifies. There is another question for you, Ananya, which is around the modularity. The question is, well, first comment, thank you for these interesting slides. If I would want to use the personal health train in a completely new area, to what extent are these building blocks or software available for reuse?
So the infrastructure that we are using is known as Vantage 6, which was earlier known as PPDLI, that is Privacy Preserving Distributed Learning Infrastructure. The infrastructure itself is completely independent of any domain or any area. The interest of domain comes in the FAIR data stations, basically. What data is there and what applications you want to run on, which are the trains, basically. So trains are basically algorithms wrapped inside a Docker container, which is again independent of the platform. So with the current version and current setup, it is completely usable in any domain in any area. As long as you have the fair data descriptions for that data in that domain, and you have algorithms which can interpret the data correctly.
Excellent. Thank you very much. There's a lot of questions coming in, which is great. I will have to make a selection also in view of the time, but what I would propose is that we also make the questions and responses, we can discuss them with the panelists and then make them available with the slides, if that's okay with everybody.
Yeah.
Here's a question for Freek, a question from Hajo Schreier from Dexis, asking us to elaborate on the difference between the personal health train and the serve data exchange approach to bringing data and algorithms together. Where do you see commonalities? Where do you see differences?
I would say that the personal health train is slightly more advanced in some sense. We are just a prototype, so that's obviously a difference. And also, I think if you would look at the differences, I would say that the data exchange is slightly more generic, even though the personal health train is also quite generic in sense. But the focus seems to be slightly more, but Ananya can comment on that, also in providing a very user-friendly interface towards selecting the algorithm, while the data exchange is more slightly focused in looking at presenting a user interface to the data provider. But Ananya might be able to comment on that. But they're very similar, I would say, in the technology and in the sense.
Any comments from you on that, Ananya?
I agree with Freek. So there are a lot of commonalities, and I guess the webinar is also aiming at that to find out the commonalities and differences so that we can work more together. Yes, there is the personal health train is more advanced in some features, but in terms of user friendliness, we are still working on it. So like an example where we can choose between algorithms, that's one option. But there are other variants of personal health train. One of the commercial variant is the Variant Learning Portal, where we can select such algorithms. But since it's not an open source and freely available, so slightly with the version that we actively work on, we cannot do that. But let's say it's a feature we can always add on. Another difference that I see is in terms of how the data station or how the data provider is allowing the algorithms to execute in its environment. So with personal health train, it is assumed that the algorithms and the data is pre-discussed, and there is a trust between the researcher and the data provider in terms of what algorithms would be run and what results would be sent back. Of course, the data provider can check back on the results. So any result that is sent back to the researcher is also, it stays as a copy with the data provider as well. So for simple classical machine learning algorithms, like that would be a simple file containing some weights or some coefficients. And if any patient data is being transported, that would be noted by the data provider. So he can prevent that way.
Excellent. Thank you very much. So it sounds like potentially fruitful ground for collaboration in the future.
Yes.
Yeah, thanks a lot. Hey, we have about 10 minutes left, so I'd like to move to the final section of this webinar, which is a merger of getting feedback from the audience and we would want to use the opportunity to also tap into your brains, as well as a bit of panel discussion to reflect on what we find. Freek is sharing the screen, wonderful. So I'd like you to open up menti.com on your phone or your laptop, whichever device you are using, and then use the code 802811. Then we have a couple of questions for you, and we'll review and reflect on those, on the answers that you are given collectively. So the first question is a bit of an icebreaker, which at least here it is slowly getting hot, so we can use a little bit of an icebreaker. The question to get you started, and the question here is, which of these video conferencing tools do you prefer? Because I think all of us have been using a lot of them lately. And I don't know how your experience is, but I continuously find myself going back and forth. So we thought this would be a nice poll to ask. This is where people can start to vote strategically. I see Teams and Zoom coming out as clear winners. A little bit of love for GoToMeeting and WebEx. The old-fashioned telephone, not so much.
Scroll down.
Yeah, and also for everybody who is doing this on a phone, don't forget to scroll down. Sometimes if the list of potential answers is rather long, then you need to scroll to the bottom to get all of the options. All right, let's move on. This was just an icebreaker also to get people activated and have you in front of your phones or your computers. First of all, this is a bit of a getting to know the audience question a little bit better, and we also want to use that to segment some of the responses that you will hopefully be given, or will be asking you to give later. Would you consider yourself primarily a provider of confidential data or a user of confidential data? And I think here it's really about what you consider yourself to be primarily. I would think most of the people in the audience sometimes find themselves in both capacities, but what would you say best describes you at this point? And that can be both as well. Let's see, people, the providers and users of confidential data are sort of on equal footing, both as well. Also quite a lot of people who are not often using or providing confidential data. Perhaps that might change after this webinar. Going to allow for a little bit of time for the last people to give their responses. Yeah, so just that everybody's aware, the results are displayed on the WebEx. So it probably works best if you have a phone at your disposal to use the phone from Menti and then look at the screen to see the results that we're sharing live time. Great, let's move on. Thank you very much. Next question, please. So to make it a bit more specific, how often did you encounter a specific need if you are mostly a data user, say a researcher, or a request if you are a data provider to share confidential data sets at your work? Just a rough order of magnitude. Never, once in my life, every year, once per month, weekly, or even daily. And for those of you who really love to analyze data and are very visual, the color coding is actually relating back to the segmentation question. But you can also just look at the overall size of the graph. Interesting. I see a histogram that consists of two pieces. There's a fair amount of people who never have encountered such needs or requests, and then a distribution that seems to peak around once a month, once a year. I'll allow for a little bit more time to come in. As that time is coming in, any one of our speakers care to reflect on this? Is this what you would expect it? Is it less? Is it more? Maybe if I may volunteer, Ananya, you are in the middle of my screen. Is this roughly what you had expected?
For me, the take would be like once per month, definitely.
Mm-hmm.
And I think roughly I agree. Some of them never, because for prototype build we mostly use dummy data and stuffs. So I agree that many people would not need data as such. And yeah, once per year for large projects, maybe that would be my take.
All right, thank you very much. Also mindful of the time, and I really will try to close at 3:30, respectful of your time. Let's move to the next one. So the question here, from any of the tools or the projects that have been presented to you today, would you expect that you want to use any of those? And we're not asking you to name the individual ones that resonate the best, but just in general, any of these tools or any of these projects, do you expect that you might become a user of them in say, the foreseeable future or today? Very interesting. So I see a lot of people who could potentially see a fit in the future, might be interested, but don't have an immediate need or an immediate use case right here, right now. And also 10 people who are just ready to go. So contact the relevant parties afterwards, and let's see if we can make that work. Excellent. Let's move on. I'm accelerating a little bit also in view of the time. We have 5 questions more, I think. All right, this is a slightly tricky one. As a provider of confidential data, so I would ask that only people who sometimes are indeed in a position that they can provide confidential data answer this. If that doesn't fit your description, then just skip this. To what extent would you want to verify these aspects before you would grant a request to share data or let people access your data? And we've 5 options here. Affiliation, which you want to verify the affiliation of the requester, the purpose or the intent for which the data will be used, the implementation of the algorithm, the output, or really the contents of any resulting scientific publications that might come out of it. And we ask you to rank them on a scale from not needed to occasionally, sometimes perhaps, to critical. If you want to skip one of these, that's also fine, then please press the skip button, because the default is on not needed. One of the technicalities that we discovered during testing. This is super insightful. So affiliation, super important, purpose, output, implementation of the algorithms, a little bit less. Allow just a few seconds for people who still want to cast in their votes. Great. Let's move to the next one, which is the flip side of this question. So now, if you are not a provider of data, but you are a user or a prospective user, a researcher who wishes to use confidential data, which one of these would you find acceptable? Would you be okay with to do that in order to be able to access the data? Would you be happy to provide your affiliation, the purpose of what you want to analyze to read the data for? Would you be comfortable sharing the implementation of your algorithm, and so on and so forth? Excellent. Thank you very much. I'll allow just a few more seconds. And then we are unfortunately coming at the end of the webinar. We have more questions for you. We are also very happy to continue the discussion offline, so perhaps we can do that. I would like to close with one more question. So Freek, could you fast forward to this question, which is, of course, well, this is the moment of truth. We are really interested to hear about your opinion about the webinar. Do you think it was valuable, or maybe better asked, would you like to see a follow-up webinar? So we'd love to hear from you if you would like to see us organize something like this again, or maybe, no, this was sufficient, not needed to do it anymore. We'd love to hear and get your feedback so we can see how we can do it again or how we can improve. Somebody is typing in the meantime. Ananya, maybe. Could you mute yourself? Thank you.
Oh, sorry.
No worries. All right. That sounds fairly positive. If you have constructive criticism, that's also very welcome, of course, either now or offline. We're always keen to see how we can improve the way we run these kind of things. All right. It is 3:30 and respectful of your time. I know we took an hour and a half out of your calendar today. So thank you very much. I hope you found the webinar interesting and inspiring. And I'd like to thank all our speakers once again. Thank you very much for your time. We also know that you invested quite a bit of time and attention in this. Thanks a lot for that. And I hope to see you all again soon. Thank you very much.
Thank you, everyone. Bye-bye.
Bye-bye. Bye.
Thanks, everyone. Thanks. Bye-bye.
Thanks for your attention.